What's up, guys? Jordan from Bennett's Customs. We are back on another episode and we're bringing it back to basics today. We've had multiple comments, a few emails, and after speaking with Carl on the phone about some future videos that we're doing together, hint, I'm going home at the end of the week. We were chatting about some stuff and he actually suggested that this would be a good video. What we'll be covering in this video is utilizing our handheld plasma cutter with CAD, cardboard assisted design. You guys have seen it. I love to use it. I would like to cover a few tips and tricks on how I utilize this straw board or cardboard in order to cut out simple shapes with our plasma cutter. So let's get into it. So first off, I'd like to explain what I'm using here. So there's a little bit of a difference between this straw board versus cardboard. So as you guys know, cardboard usually has the sort of fluted internal, and this doesn't really work that well with plasma. The straw board that I usually use, they come in different ounces, which is the kind of thicknesses of them. And I usually use a 24 or a 48 ounce straw board. You can get it at all the craft stores. It's a little bit more expensive, but it definitely holds the rigidity and you can get a really nice clean cut, and it's great for making templates. I use this stuff all the time, whether I'm building, a fuel tank for a car or a complete, engine cradle like you've seen with the split window. And once you kind of get the hang of it, obviously the possibilities are endless. And I would just like to cover a few basic shapes, kind of going into the details on our handheld plasma cutter. This is the Razor 45 amp Unimig kind of razor cut, I think they call it. This is a very versatile machine, and I really like how it's portable because I can use it for anything from cutting stuff off or cutting floors out of old cars. I can cut up to about 1/2 inch with this. Anything more, it doesn't really like to kind of give you a nice clean cut. It cuts everything from mild steel to stainless, aluminum. Depending on your thickness that you're using is kind of where you want to understand sort of gun control, I'll say, to your amperage. So, with thin sheet metal, you can obviously speed up the pace and you don't have to have as many amps going through it. Whereas if you're getting up into the thicker material, you obviously want to slow down your pace and turn your amperage up. Before we get into any cutting, number one, you really want to make sure that you have a good clean tip and electrode in your torch itself. I usually run the kind of 1 mil cutting tips, or they're 0.9. I kind of go through these a fair bit because I really like to know that I have a really clean electrode and tip in order to get the cleanest cut possible. Can't stress enough, if you have a really nice sort of setup in your torch, that's going to reflect heavily on the cutting of your material. So you can see this is a brand new tip, and the hole is very small and precise, and that is the cutting size. This one I've used for quite a while. You can obviously see that it starts to burn out and open up the hole, which is going to open up your cutting, and it sort of flutters a little bit as well, so you're not getting a really clean arc all the way through, as well as your electrode. You really want to make sure that you replace these after they start to burn out. So I'm just going to put this one back together. So what we have here is our little air diffuser. This is our electrode insert. We then have our electrode that threads onto the end of it here. And then our actual cutting tip goes on the end of that. And our shield or our cup goes over top and screws in. And you want to make sure this screws in all the way because there is like a little stop or sensor in here, so it won't allow it to work properly unless this is actually fixed in. Before we're going to actually make a cut, I mentioned it before, you really want to be comfortable in the state of where you're going to be cutting. This is really going to reflect when we go to trace our material out in the cardboard. So I usually always run it over top of my sort of my shoulders, and this way there's nothing to be able to catch on any of the material. So it's really comfortable. It's kind of, it's nice and stable. Cutting again, you definitely don't want to be pushing this thing. It will not like it, and you will not get a clean cut if you're doing so. The tip will actually catch a lot, and it just doesn't work. So pulling towards you is going to be the biggest thing and kind of the only one you want to try and do. So you can see and I would always do a test pass before actually cutting. I'm making sure nothing's going to be in my way. I don't want my elbow to hit anything, and that's going to obviously bump and obstruct the material, and that's going to leave a mark in it, and it's going to be really hard to get out. So you always want to just run a few test passes. Because we're only cutting through 1 mil steel, you definitely don't need to have the amperage that you would need for a thicker material. So we can turn that down. I think I'm running right now about 40 amps. So we're just going to turn this down to about, say, 25. I'm just going to cut a few strips off, and then I'll show you, and then we can kind of work into the thicker material, and then we'll go into the actual cardboard itself. So on that one, probably could go a little bit faster, and that will kind of give us a little bit cleaner of a cut. There's definitely still a fair amount of slag that's kind of stuck on that edge. Running about 25 amps, so I'm just going to try and turn it down maybe, and we'll give it a go. That one is about the same, but you can see how you can create all different shapes. It's purely how stable that you can be, with going. So the more fluid you are, and you really want to make sure that that cutting tip is directly 90 degrees to your material. And I'm not pressing too hard. I'm just kind of letting the torch sort of sit on there, do its thing, and then I can kind of cut the material up. But I'm definitely by no means pushing down or really hard on it at all, especially when you're going to come into using the cardboard. If you have some scrap steel like I do, just go out, cut out some shapes, kind of get used to the machine itself. All right, so what I have here is a little drawing that I've done for you. So as you can see, quick explanation, this is the material we're trying to cut. Here is our straw board, our template that we are using, and then we have our shield and our cutting tip, and then this is the arc that we are cutting. So we do know that this arc here is 1 mil. So we do know that we want this cutting edge to be accurate to the size that we want. So because the contact point to our straw board to the sort of 45-degree angle of our tip is going to not be precise to right here. So if our template has to be accurate enough to travel right through here and be the exact same size as our straw board, we need to make sure that this tip is cutting on this line. So what you want to try to achieve is, if you can, I'll show you how I set it up, but I'll measure the distance between the inside edge of our cut point to the edge of our straw board. So whatever this distance is has to be subtracted out of our straw board or our template. So this needs to be trimmed off. So I'll show you how I do that as well. But this is kind of the crucial part, that we have to eliminate this part here in order to have this inside line of our cut line directly on the line here. For those of you guys that are using the sort of more square tip, this could be a little bit easier for you to do the math in order to figure out, because you do know that the material is from center to the outside of this is the kind of size that you need to eliminate. When you're using the more angled tip or the sort of 45-degree one like we have on the end here, it's a little bit different because of the contact point that that's going to make to the straw board. What I'll do is I usually put this down on top of the material that we're going to cut out, making sure that it's flat, sitting kind of in a nice position where I can measure it. If you have an edge, it works a little bit easier. But what I'll do is I'll put this down, and I know that I can already see that there's a gap. And then I can measure, and I know that I already know that it's about 3 mil because of how many times I've done this. So I know that this is 3 mil here that needs to be removed off of our material. So then I would set this at the 3 mil sort of desired bit that I want to cut, and I can run this around the entire shape. You have a line that we can cut off. If you're not really confident in cutting right up on the exact line itself, you can take that 1 mil out of the tip and bring it back to the other side of your cut line. That'll allow you a little bit of wiggle room when you're going to clean up or finish the template out of steel. Sometimes it helps to cut out 2 of the same shapes. So you got your one, shape that's cut into your cardboard that is your main one. That's the exact sort of size that you need to use as your template. And then you have your one that you've trimmed back the edges all the way around in order to get that desired shape. When you have that, if you have your main one, you can put it down on your material and you can see how much needs to be taken off. So if you still have a little bit there after cutting that you can kind of come up to, a big thing is what I like to use is a Sharpie, sort of the big Magnum one. You'll probably see Carl uses this a lot in his videos as well, and it does work out for doing a bit of layout. Otherwise, you could use like a machinist die or the blue layout. So what I'll do is I'll run it along the edge here. I'll let that dry. I will take our main template out. I'll lay it down and say, okay, we need to come up to this edge. Again, this cardboard works really well for being able to scribe and give you a clean line. So now I know that I have a really nice line that's clean. That's the exact one as that I can kind of grind up to. So if you guys are enjoying this channel, make sure you like and subscribe. That helps out a lot for us. And if you do want to support the channel in another way, we do have the merch store. We have 20% off at the moment. We got some new graphics and some original kind of standard tees out, and we have some hoodies available for all the people that are obviously in the cold front at the moment. But yeah, jump onto the store, 20% off, and have a squiz. All right, so what I'm gonna just do is, as a simple shape, is kind of a sort of an important one, I suppose, that a lot of people would be creating, is just like a tab. So it's just gonna be something similar to this, and then we'll run a hole in it, and that's gonna be like a weld-on tab for some sort of attachment or a seatbelt tab or something like that. But at least I can kind of show you what we're trying to create. When I'm doing my layout on the straw board as well, I never really use a Sharpie because I don't like the thickness that this puts it out. So I want to be a little bit more accurate. So I'll end up always using a scribe or like a ballpoint pen, and that way I can kind of get a bit closer to the exact size that I want. So I'm just going to roughly lay out a tab, and I'm just going to go with, say, we'll go 3 inches wide. It's really fun to sort of lay all this out. And the best thing is like, even when I was doing those motor mounts, you can create all these and you can even cut this hole out as long as you know your measurements. You can use these and actually put them up into place, throw a bolt through them, and it'll really show you if you need to add a little bit more. If you don't get it right the first time, just keep cutting or add a little bit of tape so you know where it is, transfer it, cut a few more out until you get the desired shape that you're after. And another thing too is, to create your template and then having to sort of cut that 3 mil, say, off the edge, you could just take that into consideration when you're creating the template. But the only thing is it might not be accurate to exactly what you want to build. So, sometimes I'm trying to do a 3D structure, so I'm taping a bunch of these together to build something that I want to create. You can't really do that with dictating removing that 3 mil off the edge the whole way. The whole setup would be a little bit different. So now that we have our layout, I need to cut this out. Biggest thing is a fresh blade in your Stanley Ipkiss. And something I don't do enough, but I should, is cutting it on a piece of glass. Biggest thing is it makes for a really nice clean cut, and it also saves the longevity of your blades themselves. Cutting it on steel, which you see I do a lot, it kills the blade right away, which is then going to give you not the greatest cut. And then we can grab our ruler that we are going to use, and we can cut these out as close as possible. And this Stanley Ipkiss is probably, you know, you could use like a really nice X-Acto blade with a really thin tip on the end to be able to do it as well. And if you're not too confident with getting up onto your line, you can leave a little bit of space, and that way you can come back and again use the linisher to sort of clean that up and have a really nice smooth radius if you want. Okay, so there you have two of relatively same templates. I can't even put these together, and we could. I do know that I've left a little bit there. I could run over to the linisher and just quickly give that a quick little sweep. I might even try it, I'll show you. Sometimes it works. It does leave kind of like a little beveled edge that you need to sort of trim off. And obviously grit as well. I don't know what this is. 120, you could probably go even a little finer, even like 220 or 240 would be good, but we'll just show you. Just grab my eye protection. Even cardboard can get in your eyes. So you can see there that we have a nice clean edge now. All right, so now that we have our two, we need to know which one. So I'm just gonna write, this is our main one, and this is gonna be our cutting template. So this is the one we're gonna use with the plasma, and this is just gonna be our one that is gonna dictate, you know, making sure that we're getting an accurate layout on our steel. So we do know that we need to remove 3 mil around the entire radius of this in order to accurately cut the desired size that we want. So I'm going to set this up. So now that we have our area, we need to remove this excess material. So back onto the ruler. So I'm going to put that maybe right in the middle. Could use 2 clamps if you needed to, but I think we should be all right with this. So now that we have the area there, I would then take my center punch, line it up with my hole we have there. Now we have the center punch hole where I would drill out and put a bolt through for fixing to something. So let's cut this out. We are using some 3 mil steel plate to cut these out, and I'm running about 40 amps, I believe. But I change it up a little bit depending on how intricate the template is. If it's really intricate and I kind of have to take my time around the corners, I can sort of turn it down a little bit because I know I'm traveling at a slower speed. Or if it's just a simple square that we're cutting out, I can kind of, you know, turn the amps down or up, sorry, and then sort of travel a little bit faster. So it's purely just going to be for what you're working with in the template that you're creating. When you're using this, you definitely want to make sure you're wearing your protective equipment, especially a mask or a respirator. Purely for the example of this video, we have the fan behind me with both doors, and I'm just hoping I can kind of speak through while doing it, and having that fan directly behind us should be able to blow a bit of this away. I want to make sure that I'm comfortable while cutting this out, so I don't want to catch on anything. I know I have this right here. I'm actually just going to cut this off quickly. Now that can't catch my gloves or my shirt. As you can see, it catches all the time. I also want to make sure I have enough material hanging off the edge of our fab table, so I'm not going to cut into that as well. Underneath, you want to make sure you have a nice clean floor space. There's nothing flammable around you. So again, I'm going to be trying to start maybe at this point, and I'm going to sort of pull towards myself. That way I'm pulling right around the edge of this, and maybe I can stop it there, or I can continue to go through depending on exactly you know, how I'm positioned and how I'm feeling during the cut. At any point I can sort of stop. We can kind of start and come back into it. You definitely don't want to start right on your start line, because that will create sort of a little you know, hole to want to puncture through, but sometimes it's a little bit bigger than the actual cutting tip, so then you're going to have a tiny little notch in your material. You know, if we were to start, I'd want to start kind of out here even, and then come into it if I was just doing one cut like that. And again, we could drill a little hole so that we are saving the electrode when we're coming through. So the position of my torch as well, making sure I keep it 90 degrees to our material, and I'm not pushing really hard against this. I don't want to push too hard and it actually want to roll over and cut the material. I'm just sort of letting the torch do its thing. I'm just trying to obviously smoothly guide it to where I want to go. Just going to do a practice pass. I think I should be able to get right to that. And then, oh, that's actually going to cut it. So I was actually just going to start there and run this right across and stop at that little point, which means this whole piece of material would then fall. So prior to that, I'm going to cut this piece off here. So I'm going to start there, cut that off. That material is going to be gone. Then by the time I cut that out, this will be sort of one piece. Nice clean cut, consistent. The speed was good. Amperages is really good. All right, so now let's go for our radius. You may have saw there, I was kind of trying to use my legs and not so much my arms. So I was trying to steady my upper body. My arms were, you know, just guiding the torch itself, and I was sort of using my legs to try and get around that radius as clean as we could. You can see that we got a relatively nice, clean, fluid cut, especially around the radius is really nice. And then there is just a little bit of slag here that we can just knock off. Or sand out. So we're just going to lay our main one on top to see where we're at from our cutting template to our actual material that we wanted to cut and our main sort of shape that we were trying to create. If we lay this on and flip it over, you can see almost nearly the exact same. But what I'd like to do is still jump over onto the linisher and just give this a quick clean and just slightly bevel the edge, and then I'll bring it over and show you what I mean. All right, so after just spending a quick couple seconds on the linisher with the 120 grit on there, you're able to get a really nice clean edge, and then I just slightly bevel so there's no burrs on the outside. But you kind of get the idea of what I'm trying to explain is that you can use this stuff to cut out. As you can see, there's only a very, very small amount of burning just in this one little area. So this is definitely reusable. You can use this as many times as you need until it's fully burnt out and you can't use it anymore. So you always just want to make sure you got a really nice, clean, sharp edge for that tip to travel on. It's not as complicated as you think. And again, hopefully I haven't lost you, but I'm just trying to explain, you know, what I've kind of learned by using this stuff, and it definitely works. So, you know, if you're creating some really you know, more advanced design pieces, this is still a very good setup. So, you know, it's a lot cheaper to be able to throw away a piece of cardboard than it is a sheet of steel. So as long as you get that template accurate and to what you're creating, you can just transfer it straight onto the steel and be able to trace around those edges. For those of you guys that are at home with a handheld plasma torch like us, you know, hopefully this will just help you kind of get a bit creative with making some really neat gussets or whatever you're trying to create on your car, or not car related at all. Hopefully you guys enjoyed that video. Make sure you guys like, subscribe, hit notifications. We'll see you next week on a new episode. I'm off to Canada, which I'm very excited about this weekend. I'm going to see family and friends and bring a few goodies home. We'll see you guys next week on another episode. And again, Carl, thank you. I'll see you soon. And yeah, thank you for kind of giving us the idea on this video. Much appreciated.